Hello everyone, I am Marta and I'm happy to be here at JuliaCon presenting the work we did on Power Models Distribution State Estimation.jl, which is a registered open source Julia package designed to perform power system state estimation, specifically thinking about the electricity distribution system. The three main people behind this package are Tom, Dirk, and I, and we are all affiliated to either Energyville or the Electrical Engineering Department of the KU Leuven in Belgium. To give you a bit of context, distribution networks are currently undergoing some significant changes in the form of increasing installations of PV panels, electric vehicle chargers, and similar technologies, which can potentially lead to voltage or current problems in the system, especially if they go unmonitored and no preemptive actions are taken. These systems are in general still not monitored, but we see that digital or smart meters start appearing in the pictures, and these changes in the systems are also calling for changes in the way these systems are managed and operated. And we're observing a transition from the usual fit and forget approach towards more active management strategies, which often imply better asset utilization and at least some monitoring capabilities. So state estimation in this context serves as a monitoring tool that takes real imperfect measurements and acts as a filter on the inevitable random errors in order to retrieve the most likely state of the network. So it is a monitoring tool that can increase knowledge and awareness on the state of the grid, and potentially state-aware control actions can be implemented on top of the state estimation. The way we implement state estimation in the package is as a generic optimization problem with equality and inequality constraints, and we do this by separating the modeling and solver layer, which is different from the standard approach to state estimation, which sees the joint development of the model and the algorithm and has a number of advantages. One of these, for instance, is that the user can focus on the modeling layer without worrying to having to rewrite parts of the solver anytime something has been changed. And this is because the solving layer has been delegated to off-the-shelf solvers, which are not a dependency of the package, but are necessary to solve the state estimation problem eventually. What are key dependencies of the package are JuMP and Power Models Distribution, which is where the model implementation actually takes place. And specifically from Power Models Distribution, we import the power flow equations, which are an important building block of the optimization-based approach. And to this package, we also owe the network data format and other important extra functionalities. But to focus on the mathematical implementation of the state estimation, in addition to the power flow equations, we have, of course, an objective that needs to be minimized, which is the sum of the measurement residuals. And the measurement residuals can take different forms as described by equations F. For instance, two popular ways to perform state estimation are by minimizing the weighted least squares of the residuals or the absolute least values of the residuals. So since we are in an optimization context, we can also replace these constraints by their exact linear and convex relaxation, or also use other objectives. Then, since we want to be able to include any type of measurement in our state estimation, we have implemented additional measurement constraints that allow to map measured quantities that do not belong to the power flow equations which has been used to the state estimation problem itself. So to give a concrete example, if we are using the ACR state estimation power flow formulation, which has as a native variable space active and reactive power and voltage in rectangular coordinates, and we want to include voltage magnitude measurements, then we have implemented this mapping constraint that allows to use also voltage magnitude in this together with this formulation. Finally, since we are in an optimization context, users can add any inequality constraint they like. And since version 0.4 of the package, we also have bad data detection and identification functionalities, which are not part of the optimization problem itself, but are an important part of the state estimation process itself. So, since state estimation is gaining relevance in the distribution system because of the ongoing changes, we believe that Power Models distribution state estimation is a handy design facilitator because it's easy to use, to extend, and has quite a flexible structure. So basically, once the input data is in the right format, the user can play with different settings, such as the type of residual definition, the measurements, and extra constraints, and find the most suitable design for their own specific case. The fact that modeling and solver layer are split allows the users to focus on the model without the need to rewrite the solver anytime something has been changed there, which saves a lot of time during the development of tailored techniques. And as far as we know, we're also the first open source package dedicated to unbalanced state estimation. Unbalanced means that we use three-phase power flow equations, which are needed to accurately describe unbalanced systems such as the distribution system. Hope this package can also be used as a framework to benchmark and compare different state estimation formulations and models, therefore increasing hopefully reproducibility and transparency in the realm of state estimation. And so the package can be seen as kind of a Swiss Army knife for state estimation in a distribution system. And this is particularly interesting in these systems with respect to, for instance, the transmission system, because in distribution system, there are some extra challenges in the development of state estimation techniques that work in practice. And also the feature of the system itself change significantly in different subparts of the distribution system. So the ability to be flexible and play with different options is quite relevant in our opinion. And the package itself is available, is registered, tested, documented, and contributions are very welcome. If you're curious about more details, you can read the paper preprint at this link. And if you have any further question, you can ask it, I guess, now or at those email addresses.